So this scramjet construction is given here. It consists in similar fashion as ramjet, but with modified ramjet, because the name even scramjet comes after the use of scramjet engine, and it is most of the time efficient when the Mach number greater than 5. And the use of Scrum technology might let us fly at a speed of more than, that means in Mach of 10. Okay. But the primary problem of scramjet engine, it needs additional launching vehicle to initiate the flight, as scramjet only produce useful thrust at speed of Mach 5. So that to attain that speed, we need some additional launch vehicles. Okay, so that is the weak side of scramjet. A poor thrust weight ratio, which limits acceleration, and the plane is also needs to be considered large to carry certain payloads. So let's make some comparison with scramjet and ramjet engines. So in ramjet, incoming air is slowed down to below subsonic levels by diffuser. It makes use of oblique shock wave to slow the flow down. Okay, in scramjet, we have some subsonic oblique shock wave will be formed to slow down the speed, which is followed by the normal shock wave to bring it below subsonic speed. Again, in scramjet, the amount of thrust generated depends on the speed of exhaust jet, similar to that of the jet engines, like duct engine. And to increase the thrust production, the increased air must not be slowed down below subsonic speed. So Scram engines are designed to perform this function. How about the Scram engines? Scram engines are an upgraded version of ramjet engine, and their name derived from that. So it stands for supersonic combustion ram engine. It is another name is supersonic combustion ram engine. In Scram engine, the incoming airflow is maintained supersonic speed. This is accomplished by diverging diffusers. Look, let's go back to the previous slides. Then we can, no, even in the next slides, we can see this phenomenon. Yeah, here. Look, we have converging sections, and we have diverging sections and converging sections. Look, in the Scram jet, we have such kind of construction, but in the ramjet, the construction is different, like this. The combustion chamber in Scram jet is also modified to operate at supersonic speed, while the combustion chamber in the ramjet only operates at subsonic speeds. And the propelling nozzle is also modified to accelerate the exhaust jet to higher Mach number. And the thrust generated by scramjet is too much higher than that of ramjet. So these are the comparison between the two. So scramjets can fly at greater speed than ramjet. That is what we have already discussed. Scramjet carry fuel and use ingested atmospheric oxygen as oxidizer, whereas rocket, actually here I am making kind of a comparison with rocket with scramjet. In the case of rocket, we carry both fuel and oxidizer together on board. As scramjet doesn't carry an oxidizing agent, they are restricted to atmospheric flights only. So scramjets are for the atmospheric flight, but rockets are above the atmosphere. We can travel to above atmosphere using, because we have oxidizer and both fuel together in rocket. So that is comparison between scramjet and rocket engine. So these are some of the summary of what we have discussed above. This is turbojet engine having compressors with blades, 5-stage compressors. We have combustion chamber. We have 2-stage turbines. We have exhaust nozzle. Okay. Again, this is ramjet engine having diffuser with this kind of shape. Diffuser of the ramjet and the diffuser of scramjet are different in constructions. Okay, so there is some oblique shock wave on this case, and then after there is normal shock waves. These are some oblique shock waves at the very beginning, and then normal shock waves are produced. And when we come to liquid rocket, actually we didn't discuss the rocket propulsion system. We'll go to that soon, but just to imagine you, in liquid rocket engine, we have fuel. There are fuel tanks. There are oxidizers and oxidizer tanks here. The fuel and oxidizer pumps are required, which are go to the combustion chamber. And then once the combustion chamber filled with hot gas, then it will accelerate through the throttle or throat, and then which accelerates, the hot gas are accelerated through the exhaust nozzles with high speed. Okay, so this is the constructional feature of liquid rocket engine. This is also the constructional feature of particular solid rocket engine. So in the solid rocket engine, fuel and oxidizers are manufactured in a systematic manner. And then the solid fuel and solid propellant, that solid fuel and oxidizer together will be exposed for burning using some igniter through the exposed part. There are various shapes of solid propellant actually. Some of them are simple cylindrical shape, some of them are star shaped, and some of them have some kind of projected areas to facilitate the burning process. So once the uninhibited surface of the propellant caught by the igniter, then it will continuously produce energy. So that energy produces a high temperature gas, and which accelerates through the throat, or which accelerates through the nozzle and produces the impulsive force or the movement of the rocket. So this is some of the summary of the liquid and solid propellant. But in the case of hybrids, we may have solid propellant and the liquid oxidizer, or any of this combination. Okay, that will be we'll discuss them later. This table will be discussed later, but just to give you some idea on turbojet engine and ramjet engine efficiency, most of the chemical rockets, like, so how are the efficiencies? The thrust to weight ratio. ብዙውን ጊዜ የሮኬቶቹ ወይም ደግሞ የእንትናችን ኢፊሸንሲ የምንለካባቸው ወደፊት እየተማርን የምንሄዳቸው ቃላቶች አሉ። በጣም ኢምፖርታንት የሆኑ ቴክኒካል ወርድስ which helps us. Thrust weight ratio is one of that, the characteristics of performance characteristics. The specific fuel consumption is one of the performance characteristics. Specific thrust. When we say specific, it is something like, ለምሳሌ specific density ስንል density per some volume. Specific thrust ስንል thrust per area. Okay. Specific fuel consumption ስንል ደግሞ kilogram of fuel consumed per hour per Newton. That is the meaning. Specific ስንል we are saying specific. If it is simply fuel consumption, then it is kilogram. Okay, there is no something behind. But when we say thrust, the unit is Newton. But specific thrust is the amount of thrust produced per meter square of the area. Okay, that is divided by area. Thrust change with altitude is another parameter, performance parameter. Thrust versus air temperature, flight speed versus exhaust velocity, altitude limitations, and the specific impulse, ISP. We call it as ISP. So these are some of the parameters which we must understand in our future discussions also. So for particular chemical rockets, it is 75 to 1. For these are rockets actually, for rockets, for turbojets, for ramjets. Rockets thrust weight ratio 75 to 1, turbojet 5 to 1, ramjet 7 to 1. So rocket is high thrust weight ratio. Specific fuel consumption in the case of rockets 0.816 to 1.428 kilogram per hour Newton. በዚህ ጊዜ ደግሞ በቱርቦጀት ኢንጂን it is 0.051 to 0.153. So these are some parameters that you can read and understand. So which one is efficient in terms of the thrust weight ratio, in terms of specific fuel consumption, in terms of specific thrust, in terms of specific impulse? በእነዚህ ፓራሜትሮች ነው የኛ ዲዛይናችን ዲተርማይን የሚሆነው። So which one is efficient? So that is for that purpose. ለምሳሌ altitude limitation ጋር ስንመጣ in the case of rocket motor, there is no limitation in altitude. Okay, we can go beyond the altitudes. But when we come to turbojet engine, altitude is limited from 40 kilometers to 17 kilometers. And then when we got to go to ramjet engine, there is altitude restriction that 20 kilometers at Mach 3, 30 kilometers at Mach 5, 45 kilometers can be achieved by Mach 12. So these are the variation of. The specific impulse that we can obtain from rockets is 750 seconds. This is the unit is second, okay? Turbojet 1600 seconds, ramjet 1004. So in terms of ISP, turbojet is giving better specific impulse. Okay, in terms of altitude, we have rockets. Rockets are selectable because we have no altitude restriction. ስለዚህ እነዛን ለማወቅ ይጠቅመናል ይሄ ቴብል ማለት ነው። Okay, let's come to rocket propulsion. ስለ jet propulsion ጨርሰናል, or air breathing propulsion ጨርሰናል. So if you have any question or on jet propulsion, please, you are welcome. Hello?
Notes from my side.
ጥያቄ ሳይሆን ማክ ነምበር 12 የሚለውን አይቼ ነበር። ይሄ አይዲያ አለው ወይስ በዚህ ሰዓት ማክ ነምበር 12 የደረሱ ይባላል?
Actually, in terms of this spacecraft which አካባቢ ማክ ነምበር 12 is achievable. Not only 15 አለ አይቶ እንደሆነ ማክ ነምበር 15ም አለ. It is actually very high speed. ግን እነዚህ አሁን even እነዚህ ሚግ 21 ማን ነው ሚግ ሱ27 ለምሳሌ it can fly up to Mach number 5 ነው። ያን ያክል ያ ማለት ምንድነው ኒር አትሞስፌር ወይም ደግሞ በጣም በቅርብ አልቲቲዩድ ነው። ያ ማለት a lot of air drags and others are there. ግን ወደ ላይ በጣም ከፍ ብሎ ስለማይበር ከዛ በላይ መሄድ አይችልም። ከፍ ያለ ሲሄድ ኤር ሬርፋይ ስለሚሆን ድራጉ ይቀንሳል እና they can fly with Mach 10 or greater than that. It is not ideal, it is actual actually. Unless how can you achieve ለምሳሌ ይሄ escape velocity achieve ለማድረግ በምንድነው መብረር ያለበት? It is for example 0.8 ኪሎሜትር በሰከንድ ለመብረር በምን ማክ ነው መብረር ያለብህ?
has to be gravity gravity skip velocity ግራቪቲውን ዜሮ ማድረግ ስላለብን ከዛ በላይ ነው መብረር ያለብን።
that is it. So yan achieve ለማድረግ ምንድነው we need high Mach number or high speed. Mach number means it indicates our speed of the speed of the motion. So let's go to rocket propulsion. So rocket propulsion is one of an interesting part that we are going to spend much time in this area. So በነገራችን ላይ መጽሐፎቹን ሶፍት ኮፒ ምናምን ታገኛላችሁ? ምን መጽሐፍ አላችሁ እጃችሁ ላይ?
እኔ ያለኝ አንድ ቼክ ላድርገው።
ባለፈው ይሄኛው ኦልድ ስለሆነ ሌላ መጽሐፍ ሪኮመንድ አደርጋቸዋለሁ ብለህ ነበር። ምናልባት እሱን ታይትሉን ብነግረን ፈልገን እንዳውርልኛ ማድረግ እንችላለን።
በሊብጂን ላይ ማውረድ ትችላላችሁ። አንደኛው ሱታን ታውቃላችሁ? ጆርጅ ፒ ሱታን 9th and 10th edition አለ። ጆርጅ ፒ ሱታን በጣም የምንከተለው መጽሐፍ ነው። አሁን ከዚህ በኋላ የሚቀጥለው ሌክቸር የምሰጠው ከጆርጅ ፒ ሱታን ነው። So George P. Sultan is one of the book. Let me check. So George P. Sultan propulsion, rocket propulsion element is one of the book which we follow. Another
እኔ እሱ አለኝ ነው።
Okay, ስለዚህ ጆርጅ ፒ ሱታን ትልቁ መጽሐፋችን ነው or ቴክስታችን ነው። Next, there is one book. Actually, I will send those books. I will send for you either the title or the book itself. So I will send you in the next with this lecture.
Okay, thermodynamics of propulsion is it necessary?
እነግራችኋለሁ። አንደኛው ዲፒ ሚሽራ እዚህ አይአይቲ ካምፖር እኔ ያለሁበት ኢንስቲትዩት በጣም በዚህ የተካነ አንድ ፕሮፌሰር አለ። እሱ የጻፈው ዲፒ ሚሽራ ሮኬት ፕሮፐልሽን የሚል አለ። ሮኬት ፕሮፐልሽን ባይ ዲፒ ሚሽራ D.P. ሚሽራ there is one professor in IIT Madras. I'm sorry, የሱን ስም ማጣት አልነበረብኝም ረስቻለሁ። በጣም ጎበዝ ፕሮፌሰር ነው። የሱ መጽሐፍም አለ እና ለረጅም ጊዜ ያስተማረበት ነው። እንዴት እንደረሳሁት እሱን መጽሐፉን ልክላችኋለሁ። አሁን ስሙን ላስታውሰው ስላልቻልኩ ነው።
ራማሙርቲ።
ስለዚህ እነዚህ መጽሐፎች በጣም clearly ያስረዳዋል። These are written in very clear manner and these books are published in from 2010 and now. Means 2010 and now means it is within this era. So within this decade. So these books are very important books. I will send them. So rocket propulsion system may be classified in number of ways. So one of the classification method is energy source. Based on the energy source, we classify rockets are chemical rockets, nuclear rockets, or solar rockets. Even the chemical rockets also can be again classified into liquid, solid, and hybrid. Again, nuclear also can be fusion, and decay means radioactive decay. And solar also እንደዚሁ classify ይሆናል በኋላ። So based on energy source, we classify chemical, nuclear, solar, and others are also there by their basic function. we classify based on their basic function. Again, based on that, booster stage, sustainers, attitude control, orbit station keeping, and by the type of vehicles I propel. Most of the rockets are propelled using some other vehicles. At the very initial phase, they propel by some other means. So sometimes aircraft can be used, sometimes missiles will propel them, and sometimes assisted takeoff will be done, and the space vehicles also can use. So we classify based on vehicle type that they propelled. By size, by type of propellant they are using, type of construction, means geometric feature or the geometric construction, by the number of rocket propulsion units, means rocket propulsion unit, various rocket propulsion units are there, so they might classify based on that, and also by the method of producing thrust, how the thrust is produced. Based on this method, we can classify them in number of ways. Okay. And what is the working principle of most rockets? When I am talking here, overall rockets, okay. So the thermodynamic expansion of gas in supersonic nozzle is utilized in the most rocket propulsion concepts. This internal energy of the propellant is converted into exhaust kinetic energy. Look, we have chemical energy that will be changed into kinetic energy, and thus and then it is converted into thrust, and is also produced by the pressure on surface exposed to the exhaust gases. So we can see what it is. Look, we have chemicals. If we take chemical rockets, we have chemicals. So when these chemicals are heated in the combustion chamber, there is heat will be produced, then thermal energy. Then that thermal energy will try to escape through the nozzle, then kinetic energy also. So in combustion chamber, we have energy conversion from chemical energy to thermal energy. And then at the throat, there is a narrow section known as throat. At the throat, there is high kinetic energy, that is escaping of the hot particles coming through the nozzle will be produced. So there it is from thermal energy to kinetic energy. So these are the conversion of energy. Okay. Similarly, the thermodynamic theory and the gas generic equipments are used for this case. Chamber plus nozzle. When I say chamber here, combustion chamber. It is not simple chamber, but the combustion chamber and nozzle are used for the jet propulsion. In the case of rocket propulsion, also nuclear propulsion, in laser propulsion, laser thermal, solar thermal, electrical propulsion. These are actually type of propulsions which we are going to discuss. Every type of propulsions have their own separate chapter. Okay. The electric system is used. Sometimes we use magnetic or electric fields to accelerate electrically charged atoms or molecules at very low gas densities. It is also possible to obtain very small accelerations by taking advantage of difference in the gravitational attraction as function of the Earth's altitude. Okay, because we have a relation with the force of gravity with the altitude. Because we developed one formula that F is equals to mass of Earth times universal gravitational constant over radius of Earth square, the whole under bracket 1 over 1 plus h over r formula will help us for this case. One thing, this person is one of most acknowledged, and still currently all the researchers, all the rocket technologies use his formula. He's a Russian scientist, Konstantin Tsiolkovsky, we call. And he developed the equation is the fundamental rocket equation. The equation is called fundamental rocket flight equation. And he developed it in 1903, okay? So that is still working. So you can get this formula, this Tsiolkovsky formula from yesterday PDF. I sent you one PDF yesterday. Have you checked?
Yeah.
So from that, how his formula derived is there. Stepwise, that formula is there. So please note down that formula, the derivation method, and if you face any challenge on when you are taking the note, please tell me. And then that is the formula which we use for the next rocket equation. So this is the working principle of rockets. Okay, so propellants are combined in combustion chamber. We have, this is combustion chamber. You see, high pressure, high temperature combustion chamber. There is a throat here, a small area on which high pressure gas comes out with a choking effect. እዚህ ጋር ብዙ ነገሮች ወደፊት የምንማራቸው አሉ። እዚህ ውስጥ በከፍተኛ ጭንቅንቅ ይወጣል። ሾክም ግን ሊከሰት ይችላል። So gas is accelerated and ejected at high velocity through the nozzle. This is the nozzle. And the imparting momentum to the engine. So the momentum is the force. That momentum is this. DME momentum ስንል ታውቃላችሁ mass times velocity ነው. And the rate of momentum is force. Okay, the rate of change of momentum is called force. But momentum is mass times velocity. Yeah, momentum and the collision impact ላይ እንትን ማየት ትችላላችሁ. Please go through that impact problem. Now the thrust force of rocket motor is reaction experienced by the structure due to ejection of high velocity matter. That high velocity matter is the hot gas, which coming out through the nozzle with high velocity. So here, this is the point where high velocity gases are coming out and which produces momentum to the vehicle, which helps the vehicle move forward. Okay, so this is what we call, and this is from the pressure at exit minus pressure at the atmosphere. A stands for atmosphere, E stands for exit. So pressure at exit minus pressure at atmosphere. You know, atmospheric pressure is we have 1.01325 times 10 the power of 5 Pascal ነው ታውቃላችሁ። So PA ይታወቃል። PE ነው የማናውቀው። Area of exit. Exit area means this area. From here to here. What is exit? Diameter ካወቅን area calculate እናደርጋለን. And exit velocity VE የምንለው ይሄ ነው። Okay, so ME is the mass flow rate. Here, mass flow rate of the propellant burn rate. Mass flow rate. Here formula ME, the dMeV over dt. When we convert it, it is just m dot v. M dot means dMe over dt. So this is the principle of most common rockets. So let's see what is time. Okay, next ከዚህ ጀምረን ብንሄድ ይሻላል። አሁን ቢበቃን ምን ይመስላችኋል?
ይቻላል።
So if you have any question. So we'll start from chemical rocket in the next class. So have you discussed about the next, especially we can take class on Tuesday, but Wednesday I can't.
We discussed with the professor that was going to teach on not this the next Saturday. So he's I think he can change to Tuesday or Wednesday.
Yeah, check all your comfortable moments and please send the message to me. በዛላ እንትን ዋትስአፕ ወይ የነን ቁጥር ውሰዱና
እሺ
በዋትስአፕም እንደዚሁ አንዳንድ ጊዜ ኢቭን ኢንተራፕሽን ሲፈጠርም ለመነጋገር እንድመቸን ዋትስአፕ እንትን በሉ።
እሺ ስንት ነው ቁጥሩ?
ኦኬ +91
ኦኬ
97
ኦኬ
94
ኦኬ
68
ኦኬ
08
Okay.
991
Okay.
እስቲ ድገመው ለኔ
+91 97 94 68 08 91
ኤግዛክትሊ ኦኬ ሶ በዚህ ቁጥር በዋትስአፕም እንነጋገራለን አንዳንድ ነገሮች ሲኖሩም በቀላሉ ለመገናኘት እንዲመቸን
እሺ እሺ
Okay, so wish you nice day.
Actually ከሞላ ጎደል በዚህኛው ቅዳሜ ሳይሆን ያኛው ቅዳሜ ሹር ነን
በቃ እንደዛ እናደርጋለን በቃ እሺ ኦኬ
መልካም ጊዜ
ኦኬ ቻው